So now some pictures instead of all that text. And we'll go through diagrams for all 10 variations now. So yes, I've actually done a diagram for each situation. And so we take our pile on the left-hand side and with vertical load and a horizontal load. The pile has an embedded length of L and a height above the ground of F. So when we're looking at a short pile in cohesive soils, we assume a stress distribution as so, rectangular. And this way, you're looking at the soil reactions and we split it 2/3, 1/3, so that the overall horizontal load is effectively taken by R3. The deflected shape of the pile is single curvature, and we have a parabolic moment distribution within the piled shaft itself. For a long pile in cohesive soils, we can get some double curvature bending, and we have this strange looking moment distribution within the pile because we have a more unusual distribution of force within the soil. These are simplified representations, by the way. As you should know, all models are wrong, but some are quite useful. For a freehead short pile in cohesionless soils, we use a linear distribution for the soil reaction and have this semi-parabolic moment distribution down the shaft of the pile. For a freehead long pile in cohesionless soil, we have double curvature bending and this double parabolic moment distribution down the shaft of the pile because again we have parabolic soil distribution of reaction. For a fixed head short pile in cohesive soil, we have a straightforward uniform soil reaction and a parabolic distribution of our moments, with the maximum moment being at the ground level. For an intermediate pile in cohesive soil, we're looking at double curvature bending, so therefore we have maximum moment maybe at the ground, but possibly further down the ground at a depth called GC. For a fixed head long pile, again, we're looking at double curvature bending, and we're looking at a moment distribution as shown here. Now into cohesionless soil with a fixed head pile, linear soil distribution and a parabolic moment distribution down the shaft of the pile, and the maximum moment is at the top of the pile. Whereas if it's an intermediate length pile, we've exceeded the ground level moment, and the maximum shaft moment is down at a depth of GC. And finally, for our fixed head long pile in cohesionless soil, we're looking at a very strange looking soil reaction with, again, a strange looking double curvature for our moment distribution down the shaft of the pile.